Okay, so in this video I'm just going to do a quick rundown on what happens with percentage error and when you're asked to solve problems involving percentage error. So if you look here, I just have a number line drawn out between 10 to 13 and I have the little half marks notched in between in the middle as well. Now, a lot of times in questions you're asked to round something to the nearest whole number or round it to the nearest 2 decimal places or whatever it is. So sometimes you don't actually get the right answer every single time, and I'll just use a video here or use this number line to explain. If I look at, say, the number 11 here and I'm asked to round it to the nearest whole number, that can be anything from 10.5 up as far as 11.49999. So basically everything, if you see there's a little gap, everything up to 11.5 without actually getting there. So with this window, there's a lot of space where you could make mistakes. Okay, so this section up here is called your lower limit or lower bound, and this one is your upper bound. Now, as I said, if you were to round it to the nearest whole number, you have 11 in the middle, but anything in here will get you towards 11. So there's a lot of space that can make a mistake. Similarly, if you went to 12, 11.5 to 12.4999999 would get there, as long as you don't get to 12.5, because, as you know, you round up. Same with 12.5 up to 13.5. It's the same thing. So there's a lot of space that you could make a mistake, and that's where we're going to try and work out what the error is compared to the actual number. So the formula used to work out percentage error is as follows. The percentage error is error over the true value multiplied by 100, and that will give you your percentage. Okay, so the two things you need to find out, first of all, is the true value of what it is, of the number of whatever you're asked for. You need to find the error from the rounded values, and you use those numbers then to find your error. So I'm just going to show a quick example of how you can use that in real life. So in this example here we have 4 numbers, 121, 46, 37 and 26. Now what I want to do is first of all find the true value of this. Okay, so that's 230. Now the next thing I want to do is to round each of these 4 numbers to the nearest 10 and see what we can get from that. So 121 rounds to 120, 46 rounds up to 50, 37 rounds up to 40, and 26 rounds up to 30. Now if you add all those up, you get 240. It's close, but it's not exactly right. So we want to work out how wrong were we to round it to that number. So the first thing we need to do is try and find the error. And so the error is 240, which is what we got, compared to this number here, the 230. So that's our error, an error of 10. Now from our formula above here, you put the error over the true value. So the percentage error is 10 over the actual value is 230 multiplied by 100 over 1. So again, go to your calculator, fraction button, 10 over 230 multiplied by 100, ST to get a decimal. So our percentage is 4.3478, blah 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 blah. So it keeps going on. So I'll write down the rough number first, 4.347826 and so on. If they want that to the nearest whole number, it would be 4%. If it was to 1 decimal place, 2 decimal places, you just round according to those numbers. So I'm going to go to 2 decimal places, so that would be 4.35%. So that's the percentage error of our number. So in this second example, it is something to do with what we had in the last section. So at the start of the video. So it says the numbers are rounded to the nearest centimetre. So the nearest number that could be was 28, and the nearest number for this one was 16. Now if we look at the page that we had in the last part, there's a big window that we can have that will get to the nearest number. So I want to work out what's the smallest area that you could get, and what's the smallest perimeter that you could get, and the largest perimeter. The smallest and largest perimeter. Now, obviously the smallest would be if we use the lower bounds from both numbers. So the lower bound when we had 11 earlier on was 10.5. So the lower bound for 28 centimeters would be 27.5. And the lower bound for 16 centimeters would be 15.5. So there's our two lower numbers. Now if I'm to find a perimeter, you have to add up the four sides. So it's 27 plus 15.5 plus another 27.5 plus another 15.5, and that gives us a total of 86 centimeters. So that's the smallest perimeter we could possibly have, having rounded these to the nearest whole number. Now the second bit I'm going to do is if we want the largest. Now the largest numbers that we could use for 28 would be 28.499999, and the nines keep going. So just to make that a little bit easier, I'm actually going to cheat a small bit, and I'm going to say it's 28.5, because the closest number you can possibly get to 0.5 without actually getting there is 4 and an infinite amount of 9s after that. Now that is almost 0.5, so we're just going to use that just to make it a little bit easier for now. So the biggest number we can get for 28 centimeters is 28.5. The biggest for 16 would be 16.5. And if I want to find the largest area, the exact same thing, add this number, add this one, add another one and another one. So it's the same as going around the square, or the rectangle, sorry. 25.8 plus 16.5 plus 28.5 plus 16.5. Sorry, just to say it again, I made a mistake with the numbers. 28.5, 16.5, 28.5 and 16.5. If you add all those up, that gets you to 90 centimeters. Okay, now if you compare both of those numbers, one is slightly bigger obviously, but they're all fairly close. Now if you're working on a trade or working in a building site or something like that, you're not going to get the numbers exactly bang on every single time. But a 4 centimeter difference isn't huge in the context of building a house. So you are allowed a little bit of tolerance, a little bit of leeway, as long as you're within the right frame of mind with the measurements. Now the next section, I'm just going to work out the percentage error of what it would be compared to both those numbers. So now the true value of the centimeters up here is 88 centimeters. That is the ideal scenario. If we were slightly below it, we would have a smaller error. So 88 take away 86 leaves an error of 2. So now our percentage error would be 2 divided by the one we expect it to be, or the actual number. So it's 28 and 16, or the 28 and 16 number, sorry. So that would give us 22 over 88 multiplied by 100. Again, fraction, 2 over 88 multiplied by 100 is 2.27. And you'll notice similarly on the other side, if we take the larger number, 90 centimeters, take away 88, that gives us an error of 2 again. Because that's an error of 2 and that's an error of 2, we'll still get the same numbers. So even though it's slightly different from what you expected, a 2% error isn't a huge difference. So that's one way you can work around it. You are allowed a tolerance, but that's how you work out your percentage error.